and we'll talk about ggplot. So this is going to be our lecture material for today. I'm going to run out of time. I'm not going to be able to fit the the full lecture in the remaining kind of 20 minutes or so that we have. So I'll get through the slides that I can, and then I'll let you guys read the rest of the slides on your own time. But I'll probably also record like an optional supplemental video, kind of just going over the slides that I didn't have time to go over. And, you know, if you want to watch that so you get a better understanding of the slides, you can. And if you feel like, I'm just going to read the slides and learn it on myself, then that's fine too. Okay. You know, as far as this, I'm not going to have like exam questions covering ggplot. Okay. So, but there will be ggplot in homework 5, which will be posted after the exam and stuff like that. So you will need to use ggplot in homework 5, and so it could be helpful there. And it's just a good thing to learn anyway. Okay, so all of this stuff is based off of the R Graphics Cookbook by Winston Chang. And if you click this link, that will take you to the R Graphics Cookbook website. Is this today's date? It is today's date. Did he update it today? Or does this just show today's date always? Maybe he updated his site today. Wow. Okay, but anyway, you can read pretty much the entire textbook online. A lot of the textbooks that I pick, I try to pick ones where you can read online somehow. Okay, or you can buy a physical copy from Amazon. It's a great book. Okay, great book. Oh my goodness, it's kind of, well, anyway, you can read it online. So we're going to use ggplot, and my understanding is that some of you have seen ggplot already if you took Stats 20 with Professor Liu, and some of you have not seen ggplot if you took Stats 20 with Professor Tsang. So we're going to cover ggplot here. I'm going to get a little bit more into the mechanics of ggplot. And so anyway, ggplot was created by Hadley Wickham and is part of the tidyverse. And the GG in ggplot stands for the Grammar of Graphics. Grammar of Graphics, system created by Leland Wilkinson, formal and structured perspective on what basically data visualizations are supposed to be. Okay. Now, a lot of times, so I'm a fan of both base R graphics. Okay, R's base graphics, and ggplot. I think both of them are very useful, and they kind of each serve their own purposes. Pretty much, you know. So anyway, I'm not going to say like you should always use one or the other. Okay, but the whole idea, the premise of the grammar of graphics is that what we want to do is we want to map properties of the data to visual properties in the graphic. Okay, and that's what we do with the data visualization. Okay, so imagine we're making some kind of scatter plot, right? And if our data is tidy, meaning that the data is the variables are stored in their own columns. Okay, you can have different columns. A column for the person's height, column for the weight and their gender and their race and ethnicity or their hair color and things like that. Okay, and meanwhile, what we want to do is maybe we want to create a visual graphic representing the data that we have. Okay, and as far as creating the graphic, there are visual properties that you can choose, like the X position or the Y position, or the color of the points, or the symbol used for the point. And if and what we're going to do is we're going to map the data properties to the visual properties. And so if a graphic doesn't map properties of the data to visual properties, it's not a data visualization. Okay, and so here's just a simple data frame. Okay, and this data frame has, you know, 6 people in it. We've got people's height, people's weight, their gender, and their hair color. Okay, and so this will be, you know, this person is 62 inches tall, weighs 120, is female with brown hair, et cetera, et cetera, et cetera. Okay, this is just some made up data. And we're going to create a visualization. And in this visualization, what we're going to do is we create a mapping between the variable height. Height gets mapped to the x variable or x position. What weight gets mapped to the y position. Gender gets mapped to the color, and hair gets mapped to the shape. All right. And so, so this is what we get. Okay. And so we can see, you know, the person who is 62 inches tall and weighed 120 pounds gets put here. The square means this person has brown hair. The kind of this reddish salmon color means this person is female. Okay. Going back, yeah, what is AES? AES stands for aesthetic mapping, aesthetics. The aesthetics are properties of the thing, okay? Don't worry about understanding all of this right now, okay? And so here we have the 6 people from our data set, right? So this person number 3, 72 inches tall, weighs 190 pounds, is male, has blonde hair, is graphed here, okay? 72 inches tall, 190 pounds, male, so it's this blue teal color, blonde hair, so a triangle. Okay, and this is our data visualization. It's taken all the properties, all 4 columns, okay, and basically all the information in this table is now represented visually here. Okay, and so the visualization, the power of a data visualization is that it allows our it allows our brain to utilize its kind of visual processing abilities to think about quantities and values, right? So it's really an amazing, it's quite mind-blowing that our eyes are able to kind of receive, you know, photons reflected, and from that, you know, we can see things, right? Like it's amazing that we can even read in the first place, that like these little like squiggles and things on the screen take, you know, have phonetic meaning, and then when we piece them together, we get the word visualization, and that represents a concept, and our brain is now able to get this idea, right? Like I can communicate to you by just putting squiggles on a screen, and you get it, right? And our brains are able to see visual information and just process that in kind of this remarkable and magical way, right? Like we can look at the sky at night and see stars, maybe not in the city, but you can see stars, and then and within the stars you see patterns, and you recognize like shapes that look kind of like people, or you know, you're driving along the highway and you look out into the fields, and you know, you instantly start picking out lines in the way the crops line up, and things like that, and so our visual processing is able to kind of recognize patterns, you know, near instantaneously, and we can do that, right? Whereas seeing just numbers, well, it's amazing that we can just look at numbers and understand that they mean something here. But looking at this just like this, 62, 67, 72, 68, 66, 65, it's hard to just say like, oh, like how tall or how short, you know, what is that, right? But when you visualize this, you go, oh, you know what, this person is quite a bit taller than everyone else, okay? And this person is quite a bit, you know, shorter than everyone else, and there's quite a few people in kind of the middle or something like that, right? Just visually, we're able to kind of pick that up, right? And so, you know, when we see data represented visually or as points or whatever, we can process the information oftentimes a lot faster, okay? And so what a data visualization needs to do is it needs to map properties of the data to a graphic, okay? And that's what we've done here. We've taken the data in this table and we've made a graphic out of it, okay? But also equally important to the data visualization process is that you have to allow the viewer who looks at the graphic, has to be able to look at the graphic and recreate the data set in their brain. Like they have to be able to look at it and understand what is the data that's being represented here. Okay, if they're not able to do it, this is a useless graphic. Okay, and so if we look at this, and I said, based on this graphic, I want you to recreate the raw data that was in here. This graphic would allow you to do that. Okay, you would go through and I would say, well, how many people are represented? And you go, oh, there are 6 dots, so there are 6 people represented. And who is this person? This person, 72 inches tall, 190 pounds, blonde hair, male. Who is this person? 68 inches tall, 165 pounds, male, black hair. And you would be able to go through every single point and you'd be able to identify, pick out, figure out all of the data that's being represented. Maybe like you'd have a rounding mistake and you'd be off by, you know, a pound or something in terms, or an inch or something by height. But overall, you would be able, if you needed to, you could recreate the entire data set. Okay. Now, if I removed this key here, or if I removed the axis labels, you would not be able to do it. Okay. And so these axis labels is just as important. Okay, in order to go from what we see visually back to the data space. Okay, and so because what we want to do is basically we have this data set and we want to be able to communicate this to another person, okay, without necessarily listing off every single data point. Okay, and instead of listing off the entire data set this way, we can show them this graphic. And by showing the graphic in their brain, they can recreate the entire data set. Not that they're recreating it line by line, but just kind of maybe we're just trying to communicate the density of certain points or things like that. Okay, and that's what we're trying to achieve with the data visualization. Okay, so we've got all right, so here's some terminology. The data is what we want to visualize, okay? Geomes are geometric objects, right? And so far, geometric objects are points, but you can also have lines and bars to have that. We have aesthetic attributes, which are visual properties of the geometric objects, such as the position X and the position Y, the color of the line or the shape of the point. We have mappings that go from the data values to the aesthetics. We also have scales that control the mapping from the values in the data space to the values in the aesthetic space. Okay, so that's going to tell like, you know, when the data has this, like where should it go on the X, and you know, when the data is this value, where should it go on the Y, and what color should it be. Guides, on the other hand, are things like legends and tick marks that allow somebody to look at the visual thing and understand what values are being represented. Okay, the guides show the viewer how to map the visual properties back to the data space. Okay, so let's just kind of take a look at our thing again. We mapped each variable, such as height and weight and gender and hair, to some visual aspect. Height gets mapped to its position in X, and weight gets mapped to the position in Y. Gender gets mapped to what color should the dot be, and hair gets mapped to what shape the dot should be. Okay, and the scales in our thing were just automatically determined by ggplot. The guides were also automatically created by ggplot. Okay, so ggplot looked at the data and just said, you know what, this lower left-hand corner of the plot is going to be some value like 59.5, 61.5, something around there, 118. Some value down here, and the upper right-hand corner is going to be some other value, right? It also chose automatically what colors it wanted to use for genders. It also chose automatically what shapes it wanted to use for the points. The guides were created automatically by ggplot, which is, it puts the tick marks and it labeled the axes, and it created a legend, and it labeled the legend as well. Okay, and so here again, this was our original mapping, okay, our original scatter plot that we started off here, okay, and we have hair color mapped to the shape, and gender mapped to the color of the point. Okay, now what I'm going to do is I'm going to swap this. Okay, so here I had hair mapped to the shape and gender mapped to the color of the point. And I'm going to kind of swap these mappings. And we're going to say hair is going to get mapped to the color of the point, and gender is going to get mapped to the shape. Okay, so how many shapes am I going to see? Okay, at least in this data set. In this data set, we have 2 genders represented. And so over here, we had, back when we mapped gender to color, we had 2 colors represented. And when we looked at hair color, there were 3 hair colors represented. And so we had 3 shapes. Okay, now that I'm doing mapping it this way, we're going to see 3 colors represented because we have three hair colors, and we're going to see 2 shapes represented for gender. And so this is what we're going to have. This is the same data, just with a slightly different aesthetic mapping. Okay, so now we have 3 colors for hair. We have red is represented, or black hair is represented with the red dots, blonde hair is represented with the green dots, and brown hair is represented with the blue dots. Females are represented with circles, and males are represented with triangles. Okay, and that's what we have here. And just kind of visually, I think our eyes will pick up colors before it picks up the shape of a point. Okay, so in general, our eyes will pick up the color of a point before it picks up the shape of a point. And so, so here, we're going to notice, we might notice something like, oh, you know what? The tallest, the shortest people in the group had brown hair, and the tallest people in the group had kind of blonde hair, and people with black hair were kind of in the middle, whereas that might not have been obvious to us here. Okay, it's this, we could say, oh, who are, as far as hair color goes, who is the shortest? So we go, oh yeah, it was the brown haired people. The 2 squares are down here and the 2 triangles are up here. Not the 2 tallest people, but like the tallest and the 3rd tallest person are up there. We might have seen that, but it's probably a lot more pronounced when hair color is represented by color here, right? So just kind of in general, our eyes will notice color before they notice shape. And so if you're trying to represent your categorical variables, and the more important one should get kind of the color attribute, and the less important one will get like the shape attribute or something like that, right? Question, is it related to group by? Choose the interest group map to color. Group by is not an important aspect for aesthetic mapping. You have different variables, and you just kind of map whatever variable you want to an aesthetic attribute, like the color or the shape or something like that. Right? Is that okay so far? What if we try something else out? Okay, this time I'm going to take that categorical variable hair color such as blonde, black, or brown hair. I'm going to map it onto the y-axis. What is this going to look like? Okay, and then I'm going to take the weight aspect, which is a numeric attribute, and I'm going to map it to the color of the point. So what is this graph like? Can we even make a graphic like this? And the answer is we can. Okay, so as far as hair color goes, we're going to take the hair colors and we're going to just put them on different locations in the y space. So we're going to say black hair is going to go on this location in y. People with blonde hair will go on this location in y. People with brown hair will go on this location in y. It's categorical, and there are 3 attributes, and so we're going to have 3 locations in y that they can be represented. Okay. Weight, which is numeric, can be represented using colors by using a gradient color scheme. Okay, and so we can say people who weigh 120 will be this dark, almost black, dark blue, and people who weigh a lot will get represented by a lighter color. This is just the default scale. Okay, and so we could say, okay, this person weighs the most because their colored dot is the brightest. Okay, this person weighs the least, their colored dot is the lowest here. Okay, and but it's a little bit harder to kind of judge, like who weighs more between these 2 people. Maybe this one's a tiny bit lighter. It's a little bit hard to tell that apart, right? Okay, we have a question. What would happen if you mapped weight or another numeric variable to shape? Okay, well, that's a good question, and the answer is you can't. You cannot do that. Okay, so But I have a slide for that. Okay, so these are strange mappings. Okay, but ggplot does its best with the mappings that we provide, right? So it takes the hair color, which is categorical, and we say map it to the y-axis. So it creates a position and says, all right, here's a position for brown, here's a position for blonde, here's a position for X. Okay, and then for the colors, it creates a continuous color scale, right? Darker represents smaller numbers, lighter represents larger numbers. Okay, and so on the surface, representing a number with a y coordinate might seem different from representing it with the color. Okay, it might feel different using whether to use it its y position with a color, but at an abstract level, it's the same. We're just taking a data value and turning it into some aesthetic attribute. Okay, whether it's positioned here on the y-axis, or whether it's a light or dark shade of a color. It's at an abstract level, this is the same, and that's what the grammar of graphics is trying to really drive home. Okay, now some aesthetics can only work with categorical variables, such as the shape of a point, right? So what would happen if you tried to take a numeric variable to the shape? You're not going to be able to do it, right? Unless yeah. So if you're representing something with like triangles, circles, and squares, that has to be kind of, it has to be categorical, right? Maybe you can say like, if you have like a very limited scope in terms of numeric values, like you can say like, if there's only like 3 unique values, effectively you're turning them into categories as well, right? So maybe the number of sides of the, I don't know, not the best, right? And other things are gonna work, could work with categorical or continuous variables, right? Like X or Y position. Okay, we saw the Y position be kind of used in its traditional numeric sense, but also in a categorical sense by just saying this level is this category, this level is a different category, and this level is a different category. And even something like color can be used with a numeric or a continuous or a categorical variable. Okay. For scatter plots, generally the X and Y are usually numeric. And for bar graphs, the X-axis is often categorical. And that's what we have. How many possible shape categories are there? There's a lot. I don't know. But generally, you don't want to abuse this too much. You don't want to have like hexagons and pentagons and octagons on the same plot because they're very difficult to tell apart, right? So anyway, that's what we have here. Okay. A lot of the things you do with ggplot can also be done with base graphics, and I wrote some code and I thought this was correct, but I'm gonna have to go back and fix it because my plot didn't come out. I don't know if you've ever tried to make a plot with base graphics and ever tried to write a legend with base graphics. It can be done, but it's also known as one of the most tedious tasks to do in R, is trying to create a legend in base graphics. And I thought I did this correctly, but my plot didn't come out. So I'm gonna have to go back and try to fix my code to get my plot working. Okay, but anyway, all to say is that a lot of the things that you do in base graphics can be done in ggplot, and a lot of the things you do in ggplot can be done with base graphics. In general, I think the ggplot notation is simpler and easier, and we'll kind of get into that here. You just kind of provide the mappings, and the graphics is created, and the legends and the guides are created automatically, which is great. Okay, but I have run out of time, and so I'm going to stop the recording here, and then I'll record kind of another video later to kind of cover the rest of the slides. That video will be optional. You can probably just also read the slides on your own time if you want. Let me give you the last 2 answers for today's viewing quiz. Last 2 answers are E as in elephant and D as in dog. Second answer is E as in elephant. Third answer is D as in dog. Okay, so we will end here, and have a good weekend, you guys. And we'll see you guys on Monday. Good luck as you study, and we'll see you then. So, but yeah, I'll record a video for the remaining slides from this ggplot thing that, if you want to view, it could be helpful. All right. Have a good weekend.